Hello students, welcome back. Now let's go to section 2. Here in section 2, we deal with a bunch of problems related to intercepts. First 2 problems are related to y-intercepts, and the next 4 problems are about the x-intercepts. Which are easier? Y-intercepts are generally easier, so let's do those first. Oh, by the way, sorry about the typo. From general form to vertex form, and then here's the formula method. And then here are a couple of visualizations. Concave up, minimum here, h comma k, range k to infinity, symmetric about the vertical line, x equals to h. Concave down, maximum here, h comma k, range is negative infinity to k, symmetric about the vertical line, x equals to h. Okay. First problem here, find the vertex equation of the quadratic function that is symmetric to the vertical line x equal to negative 2, has a maximum 3, and the y-intercept negative 1. We're looking for the vertex equation, so basically this is what you're looking for. Okay, alright. Now, please look at this equation carefully. We have 3 parameters to determine, a, h, and k. And that's typical for quadratic functions. In general forms, we have 3 parameters, a, b, and c. Likewise, in the vertex form, we have a, h, and k. 3 parameters to determine, so we need 3 pieces of information. What do we have? The vertical line x equals to negative 2, and the maximum y equals to 3, and the y-intercept of negative 1. 3 pieces of information for 3 unknown parameters to determine. Yes, we can do it. This problem is well posed. So, symmetric to the vertical line x equals to negative 2, that means h is negative 2. And about the maximum, that's k value. Sometimes maximum, sometimes minimum, depending upon the sign of a. And then y-intercept is negative 1. What do you mean by that? This equation runs through (0, negative 1). You see y-intercept, so it runs through the y-axis where x coordinate is 0. Let's do this color coding. That's the third piece of information. That's the first piece of information. This is the second piece of information. So that's the equation you're looking for. And h is negative 2, so this is x plus 2 squared. And k is 3, so this is plus 3. And over there, x is 0 and y is negative 1. Plug it in there. And from here, can we determine a? Yes, we can. So minus 1 equals to a times 0 plus 2 squared plus 3. So 0 plus 2 squared, what is it? It's negative 1 equals to 4a plus 3. So a is negative 4. Did I do this right? Therefore, y equals to negative 1 of x plus 2. squared plus 3. There goes the vertex equation. So symmetric to the vertical line, blue, maximum 3, red, h value, k value, and we have one more character to determine. We have to find out what a value is, and we use x is 0 and y is -1 from the x-intercept. Here's the next problem here. Symmetric to the vertical line, x equals to -1/2, has the minimum -2, and the y-intercept of -1/2. Look at the structure. The same structure? Can you use the same method and do the same thing? You should be able to do that. Okay, I'll stop here. The answer key is available here. So you see, you can open up and get it. Oh, excuse me, no answer key, just the answer here. Just the answer, no answer key. Okay, all right, in that case, maybe we should do that. Try on your own first. Okay, ready? All right, symmetric to the vertical line. So h is -1/2. So this is the same as +1/2 squared. Minimum -2. So k is -2. So -2. Now, y-intercept -1/2. So here, I'm plugging in xy equals 0, -1/2. So if I plug in y equals -1/2, 8 times 0 plus 1/2 squared minus 2, so what is it? Minus 1/2 equals to 8 times 1/4. Let's remove all the denominators, multiply 4 to each. So I'm going to get -2 equals a minus 8. Is that right? Multiplying 4 to each. A is, am I getting 6? Y equals to 6, x plus 1/2 minus 2. Is that the solution? Let's open up and check. Yes, indeed, that is the solution. So yes, everything is correct. Oh, by the way, we have graphical justification too. Never mind about this. I don't know what this is all about. I thought it was graph, but it was not it. Never mind about that. Anyway, here's the answer key. Okay, do we have enough time to go to the intercept form and then do some problems about x-intercepts? I think there's enough time, yes, but it's a drastic change of topic, so I'd rather stop here and start afresh in a separate video. Let's stop here.